Welcome to the second set of video notes where I talk about energy. Specifically, I'm going to talk about specific heat in this video. And just like the first video from this series, at the time of this recording, this falls under Unit 8, ICANN Statement 4, but that might be subject to change and you might have to change your heading. So I'm going to start by defining specific heat. And anytime that I think about specific heat, I always picture eating pizza. I'll explain why in a moment. So the definition of specific heat is kind of lengthy. So you'll notice I sped up my writing here because it takes a while to write. But it's the amount of energy needed to increase the temperature of 1 gram, 1.0 grams of a substance by 1 degree Celsius. And the reason that I always think of pizza is that when you bite into a piece of pizza, you typically, if it's a nice hot piece of pizza, you'll typically burn the roof of your mouth, but not your tongue. And the reason for that is because unless you're eating that pizza upside down, the sauce and the toppings are on the top and the crust is on the bottom. Well, the sauce has a lower specific heat, while the crust has a higher specific heat. So if you cook them in the same oven, which I don't know any other way that you would cook pizza, you're subjecting them to the same amount of energy, but the sauce, since it has a lower specific heat, will heat up to a higher temperature. And the crust, since it has a higher specific heat, that means that a higher specific heat, it takes more energy to increase the temperature of that substance. So if you cook it at the same energy of the sauce, it won't heat up to the same temperature as the sauce. It'll be cooler than the sauce and the topping. So a higher specific heat means it takes more energy to heat it up. So I always think of pizza, and the reason that you burn the roof of your mouth when you're eating pizza and not your tongue has to do with chemistry. The units that we use for specific heat are a little bit involved, but they'll make more sense when we look at the specific heat equation, or the calorimetry equation. But it's joules over grams times degrees Celsius. So essentially it's a combination of energy, mass, and temperature. And we use specific heat in a fairly complex looking equation, but it's actually quite easy to apply. It's called the calorimetry equation, and it is Q equals M times S times delta T, where Q is the energy of solution, or sometimes it's just called the energy. You might also see this uppercase Q written as a lowercase q. It just depends on the textbook that you're looking at. But it's the energy of solution, and that is measured in joules. So the units for energy are joules. We have several units of energy. Those were discussed in the last video. Then M, obviously, is mass, and this is measured in grams. The S is the specific heat. I always like to use S for specific heat. However, you will see certain textbooks and worksheets use C for specific heat. Not sure why. S makes a whole lot more sense because specific heat starts with S, but there you have it. So that's specific heat, and the units for specific heat are joules over grams times degrees Celsius, as we've already written above. Finally, the change in temperature, that delta T, is change in temperature. And in case you've forgotten, when we're looking at a change in something, we always take the initial and subtract it from the final. So it's final minus initial. So if we're looking at change in temperature, that's going to be TF, or temperature final minus temperature initial, and this is measured in degrees Celsius, always degrees Celsius. So as I said before, this is known as the calorimetry equation. And calorimetry, again, it sounds really complex, just like the equation above, but really, calorimetry is just looking at the relationship between heat, energy, and temperature. So when you look at this equation, it might seem complex, but if you can step back from the letters and the numbers, really all we're looking at is if I apply this amount of heat to this much of a substance, what will the change in temperature be? And the specific heat is just, well, what's the substance? Because I can apply the same amount of heat to pizza sauce and pizza crusts, and they will change to different temperatures. So calorimetry just looks at the relationship between heat energy and temperature. Okay, so last thing, I want to show you this little worksheet where I have two different sized pots with different amounts of water in them, and they're starting off at the same temperature, and they have the same amount of heat applied. Which of these two do you think will have a greater change in temperature?